Hello civil engineers, welcome to my YouTube channel. Today in this video I am going to show you how to design beams in RCDC. So to design beams in RCDC you need first of all to have STAAD Pro Connect or STAAD Pro V8 so that you can be able to model and analyze your building in STAAD Pro, so that you can transfer the results to RCDC and you can be able now to design your beams. So you need at least the two softwares. Okay, so I'm going to open my model in STAAD Pro. So I'm taking a bit of time, please don't bear with me. So let's open. So here is my model. I'm going to open my analytical model, which I have already modeled. So I'm assuming that you already know how to model and design in STAAD Pro, okay, and also do analysis. So to do analysis you need to come here, and of course if you have filled all these commands, you have the code, you have the clear cover for beams, clear cover for column, you have the strength of concrete, you have the strength of steel, you have the command to design beam, design column, everything. So after you've done all that, after already modeling and assigning the sections for each column and beams, okay, so I hope my analysis are still up to date, but I will repeat the analysis just for the sake, so that we go straight to beam design in RCDC. Alright, so I'm going to go straight to advanced. So RCDC, remember you need to have this RCDC and to have STAAD Pro, right? So you can see there are two different but softwares that work together. STAAD RCDC Connect edition. So I need just to show you that you need RCDC, because without that you cannot. If you just click if you click where I did, it will tell you that you don't have the license. So you need this software, this one here, and you need this software. Alright, so I'm going to give the project a name. I'm going to give it sample, client, viewers, and then engineer Geoffrey. Right, so I'm going to go to beam design, and if you see my model, so I'm going to open the architectural. Let me open the architectural model, and there's one important thing that I also wanted to show you. Let me let me open a new model. just open a new empty, and then I'm going to import. So I'm just going to open a new start drawing so that I can show you the architectural, right? So I need to come here. Where is it? Insert. Then I need to go to import. Then I have the architectural drawing right here, so I'm going to import it, so that there are some things that I need to show you. But in the meantime, I can just go ahead and go back to my model in STAAD Pro, so that I try to show you something. So actually I'm going to do design the beams, and I'm also going to detail the beams in my Auto Cad. So I'm going to just to show you everything in this video, so that you will not be left with some questions. So please wait. So if you can learn STAAD Pro, I think STAAD Pro, in my viewpoint so far, is the best I've learned, because I have learned 3 different software. One is Prota structure, the other one was ETABS, and this STAAD Pro was the last one. So Prota structure was okay, but there were 1 or 2 difficulties, and ETABS also had certain difficulties, in terms of there are some things that you can't solve. Like I tried to solve the issue of overstress, and no one could tell me really what the solution was, because my columns were not supposed to be failing, but they were all overstressed, all my columns. And I think there is certain element that I did not design. Maybe the stiffness, maybe, I don't know, but I don't know why my columns are failing when they're not supposed to. So I got tired in between learning ETABS. So I found, to my viewpoint, that STAAD Pro is a bit easier to understand and to master, right? So in this video we are actually going to design and detail. We want to detail everything in Auto Cad, okay? Please don't mind, it is taking a bit time. It takes it time to import PDF, because it's architectural drawing. It's actually a building, a school, which was really done in real life. So we are going to learn, because we are using real life project, and what we do here is really what is practical. Okay. Yes, it takes its time. So, but at least you know how to import a PDF into AutoCAD. So you just need to go to insert, then you can just see PDF import here and then click it. But not the other way around. Not there are some people who tell you to go and I don't know where, then import. No, this is the best. This is how it works. Go to insert, then import. So yeah, and please watch my video to the end, and please bear with me because my laptop is a bit slow, but I can guarantee you I have very good content for you. And if you are going to feel that you have gained something from my video, please, you can support me. You can subscribe and hit the like button. I'm going to really appreciate. That's the only way you can support me. So even me, I'm running out of patience. Please bear with me. And then that's the issue with AutoCAD. AutoCAD takes a lot of space of your computer. And one thing I can advise you, if there is other way you know how to detail in a way that you can avoid AutoCAD, it is better because AutoCAD takes a lot of your RAM. So you find that it makes the laptop slow. So for those engineers who have experience, they normally would avoid AutoCAD and go for ArchiCAD. So but for me, unfortunately, I have not yet mastered ArchiCAD, although I have it in my laptop, but I have not mastered it, so I cannot go to detailing ArchiCAD. So if you're good in ArchiCAD, you can just avoid AutoCAD because these problems. You can see it is taking a lot of time. If it was ArchiCAD, I would just pop 1 minute and my drawing will be here on the screen. So this is the problem with AutoCAD. So for those who use Prota structure, you can just do most of the work on Prota details, and I have uploaded a video for that, so that when you go to AutoCAD, you're just doing the finishing touch, and then you can print your drawing and then give it back to your client, right? So in my channel I have really good content for you, so I only need you to support me by subscribing and liking my videos, and that YouTube is going to, you know, promote by to somehow promote my videos. So let me click escape because I have selected what I know. I need to select this and copy it down there. But I need to show you something before I go to because we are going to detail. That's why I need this architectural, because we are going to detail. Alright, so please be patient a bit. I'm going to copy this right here. So let me first close this because I want to show you something. I need to go back to STAAD Pro. So I'll go to view, I'll go to 3D rendering view. So as you can see here, I did not do the entire structure. I did just halfway the model, you know. So if for instance, if you look here, you can see there is some sort of symmetry. Let me show you. There is some sort of symmetry, X, L, H. So if you check this out, okay, let me give this line another color. You see this is like the center of my structure, right? So there is symmetry. There is two symmetrical structure in this building. There's two symmetrical. If you look from the plan, there's symmetry. So what you need to do, if just I could show you, let me click the polyline, just do there, up to there, up to there, up to there. So you don't need to design the entire thing, because it will take your time, and an engineer who has experience would not do that. So even when you come to detailing, you will take a lot of time, because you're detailing the entire structure. So go there, then there, then I'm going to give it a different color. Click escape. So I'm going to give it a different color. I give it green, and then we give it a different thickness. So you can see this structure. There's another structure up here which is symmetrical, which is like, if you look at the mirror, it's like same. It's like twin. It's like duplicate, right? So you don't need to do the whole thing. So I'm gonna come right. Let me do this. Then I'm going to come. Actually, it was not there. I need to delete that. Okay. So that's why it was bringing. There's another symmetrical object. There, there, there. Oh. No, what is that? I need to polyline, not so from here. There, there. Yeah, then I think there, then I've made a mistake again, because you can see the way this one looks like. There is something confusing me there, so don't mind, please bear with me. So there, 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 there. There, and then there. Then we close it, then escape, then let's select the tiling, give it another color, then another thickness, and then by layer. So can see the two blocks that are symmetrical. So what I'm gonna do, what you need to do is to design one of these, either the one on the upper side or the lower side, and then this portion, this small portion. But it is not advisable for you to design like this way, because it is not it's not that symmetrical, but just this is similar to that. Alright, so I'm going to design this only and this portion, and not the other way, to do up to here and then assume not like that, unless it is a square or a rectangle. Right, so this shape you can do just this and this, and then the upper side you're going to use the same principle as this now. So that's how we did here, as you can see. Alright, so let's go back to RCDC. So project, sample, client, viewers, and then engineer Geoffrey. I'm going to use BS8110, and then I'm going to its beam, then these and these and these and these. This one is the water tank which you saw. So this is the first floor, second floor, third floor, and the roof, which is also slab. Okay, so I'm going to create project. So it is taking a bit time, so don't mind. It is reading the analysis model from STAAD Pro Connect. So this is our STAAD RCDC Connect edition, right? Advanced concrete design, and this is the best. So if compared to the RC designer in STAAD Pro, this one is the best. So if you have this, go for this. All right. If you have this RCDC, if you have license, you go for it instead of RC Designer in STAAD Pro, because RC Designer it's not going to give you the drawing, and you know what you need. To be fast, you need also a software that can give you the drawings, all right, so that your work will just to be, the final touches before you give it back to your client. Okay, so here we go. So you can see our beam. So this is up to the roof. Okay, so I'm going to go to setting, general settings. Okay, first of all, I don't need these beams for like 600. I need to change this somehow. I don't know. Okay, I will change it during the design. I don't need 600 because that is too. We need to avoid that. Okay, the other thing, I don't need this code. I need the Euro code. Wait. I don't need to use this code, so I need to use the Euro code. Project setting. Let me go back to project setting. Cancel. Let me first the project information. I need to change this to Euro code. I prefer Euro code during the design, because I found Euro code is giving me exactly as I want. Because if you do this with BS code, you find it give you side face reinforcement for torsion, because I don't know why, but I don't want that. So let me first exit. I don't need to use that code. Go back. I need to use Euro code. So sorry for that mistake. So let me configure it with Euro code. I'm going to Euro code. Wait. EN Euro. Not United Arab Emirates. I need Euro, or I don't know. Okay. We go fast here. Open. EN. Yeah, I need to use EN. Configuration. So should be country. Maybe UK. I don't know. But this one is okay still. Just EN. Project. Sample. Client. Viewers. Engineer Geoffrey. And then beams. Then 1, 2, 3, 4. Right. Create. So this 14 is the water tank, so it's different. It's only for the water tank, so click that. It will not allow because the floors are not symmetrical. The last floor is different from the others. So I prefer Eurocode when I'm designing beams. You know, everything is based on the results, because personally I don't want side face reinforcement. And side face reinforcement is for torsion. So how you deal with that is that when you're designing in STAAD Pro, you can assign the stiffness in columns and beams, because the stiffness in beams should be 35%, that is 0.35, and the stiffness in column should be 70%, that is 0.7. But if you don't assign that, the software will assign 100% for beams and 100% for columns. That is 1 and 1, which will make torsional moments, which will then necessitate side face reinforcement, which is not necessary. Right? So you need to check, you need to ensure you do that during your modeling. And you also need to do what you call moment and end moment release for secondary beams. So that's how you do it. So it's reading, it's taking its time, so please bear with me. Okay, done. So I need to go to settings, general settings. I check that and then put it at 0.1, and then I will check this ductile. I will check that all beams will be, and then base fit there is okay. Then I need to use class 16. I used to use class 460. Clear cover is 25. My clear cover is 25, and then I need to use 16, then 16. So I think that should be the minimum for beams. If you want to be an engineer, you should know these things. Okay, so shear can be that. Side face, just put 8 for shear. Side face reinforcement, I don't think we will need it anyway, but we shall see. So I need the spacing for my links to be 200 and 200 only. So that's it. Okay. To respond, please let's give it some few minutes. So we can see the T sections have come, but from this one we can easily tell that this one is an L section, because the T section means there is slab on both sides. That is the T section. This one is an L section, so we can just give it L. Okay. So this one is L, and this one is L. Also for this side, it's L. This one is L. This one also is L. This one also is L. This one also is L. Then come here, L. This one is 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 L. This one is, and that's the last one. So we go to this L, also L, L. Then the last one is rectangular, I guess. Yeah, rectangular. We go to this that one, rectangular, then L. This is L. This L. Okay, these all of them L, I guess L, because it basically means that slab is on one side. This one can be T, L, 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 and this side also this one is T, this one is T, this one is L, this one is L, this one is L, and that one is L. Okay, now we go to the other setting, rebars and curtailment. That don't change anything. Detail and drawing, I'm going to go to here, then I'm going to change this one to Y. Okay, go back, share, just Y. I need to use the hashtag, that minus sign for all. Yes, the val also Y. Okay, okay, then I'm going to you can either design, go here to design, or come here, it's just the same. Okay, just add. So DF is basically the very important, is basically the depth of the slab. The depth of slab is 150. So I'm going to copy, I'm going to paste. So I'm going to paste. So all of them, maybe you can import slab data. Import slab data, go to S4. Okay, slab not found. So just need to do it manually. Unfortunately, no. Last time don't not do that. So I need to save this. Okay. Yes, I was not supposed to click design before. I'm trying to avoid to do this manually, each one. Just going and typing 150. So maybe let me show you. Let me show you another trick. Let me first exit, then go back. I don't need to I don't need to write that manually, because I shouldn't have designed before, just put here anything. So there are several tricks in these softwares which you should learn. Sorry for that. I don't need, those rows are too many, so I didn't need to type manually. But I will not repeat some things, because I will just assume everything is T. Then give the depth at 150. You will see what I mean when it finish loading. Because I think if I was typing that 150 each row, it will take more time even than just repeating this, because I made a mistake in one step. So I'll just go fast. I will not need to explain everything because I already did. Just I need to go back to where we were. And I think on the detailing part, I will do it as part 2 of this detailing of beams. So this will be part 1. So I'll do it as part 2 because I don't want the video to be too long. So it's hanging. Even me, I'm running out of patience. Please bear with me. You will get what I mean in just a few seconds. It's taking too long. Anyway, it's just what it is. It is what it is. It is what it is. Reading in progress. So the flange, so first of all I need to make sure general setting. I need to avoid that at 0.1. Then it's ductile, and it is flanged in all, and here of course was plus 16 or 60. So just need to do this, then df 150, right? Paste is grid, copy and paste is gridded out. I don't know why. I don't know. So you need, this is dead load, this is live load. I just need the two, and okay, this is for regular structure. Okay, so they are filled beam groups. Okay, so we're going to solve the beam that are failed. Okay, design. There is probably one beam that is failing. It is beam B39. 39. Where is it? This one. So I need to increase it to 550. Then design. Clear cover first of all is 25. So you can see the beams are failing in shear. Okay, so I will need to change the distance because I think 200 is the problem. It's too big. So cancel this. So I'm going to settings. First of all, I will unlock. Settings, general settings, and minimum shear should be 150. Then 150. Okay. And I will design. Okay, now all the beams are passing at a spacing of 150. So there is no side face reinforcement, which I really like to avoid. Okay, so I'll save this, then go to reports, can get the calculations. Just get for all beams. So yeah, the calculations, can print calculation. So that's why I like the Eurocode, because it is not giving me the side face reinforcement. You know, I don't really need the side face reinforcement. Which is really unnecessary. That's why I avoid BS code when I'm using RCDC. So I just save it there. Just save it beam sample. Save. Then I'll go to reports, then elevation and section, then all of them, then cross section, then I just get cross section, not cross beams, and okay. So you can see no side reinforcement. Can see now I can first need to save this, then I can export this to Auto Cad. Can save it as a DWX file. I will save it in desktop, beam sample. Okay, save. Then anything else, can get the failure diagnostic. So none of the beams has failed. Then bill of quantities, BOQ. You can get the BOQ. Okay, then let us go to detailing. I see my beams are just here. So what I need to do, I need to come back here, design, and we go to input, then we go to input, then I'm going to save this as sample plan. Okay, save. Then I will open plan. I will do some editing here. Select similar, then I give it by block, then do just a bit editing. Then properties, then I'm going to use oblique size. I'm going to use 2, and properties again, and then I'm going to use text height. Color, I'm going to put black and white. Then no problem, I can use 350. Then I can come text style. Okay, I can come to annotation, come to text, then I can manage styles. I'm gonna need to add another style with area. So I'm going to add new style. I'm going to name it area, and okay, and then I'm going to put it area regular. Okay, then apply and close, then select similar, properties, then I'm going to give it area. Anything else? Now I can take this, copy, it here, then we need to start with beam 310. This is beam 1 and beam 2. So I think beam 1 and beam 2 is here. So beam 1, beam 2 is this type, and at the support, so I'm just going to carry these two. Okay. Then copy, I'm going to name it beam P, rotative, then multi, beam P, that is 450 multiplied by 200. So I need to change this. Properties, style, give it area. I'm going to add another style first. I'm going to do annotative, manage style, new area bold. Okay, then still area but bold. then text height is going to be 200. Just put text height still 350. Okay. Then I'm going to delete that. Okay. I'm going to copy that, put it there, put it there. And then I need to come to beam number 3 and 4, still P. 5 and 6, all these are P, right? 4, okay. Game 17. Now this is number B. 11, okay. So up to number 10, they are still this one. So it is up to beam 30. I think beam 30 is still right here. Beam 24, just the same. Beam 30, yeah, it's still, beam 30 is still like that. Then this one is beam, beam 31, beam 31, that one is now this one. And I'll copy this from there. Beam M600. by 200 and copy. All these are that kind of beams. Then I think I have only those two types of beams. Then there's this beam number beam 44, so different. Now this will be, let me copy this from here. This one X. I think the rest are beam P. So copy. Then the next step would be to remove these dimensions from here, take them down, move. Then move these ones also down, move. Then I'm going to find the midpoint, right? So let me take the grids back. Okay, the grids are not going to help me, so I need to offset this by 1000. Then I need to trim and I need to find the mid center point, the midpoint. So I need to come here, midpoint, then XL H, then the midpoint of this is there. Then I need to trim also. I need to come and copy everything. Remember what we needed to copy. Remember, we need to mirror this, only this to the other side. Okay, so we need to mirror that. So after up to there. And mirror then erase the source object. No. Okay, now we have finished detailing. So what we need to do now is to then mirror this also about a straight line. Okay, just like that. Now this time we delete the source object. Yes, so we also mirror these, then mirror again because they are now upside down, and do a straight line, then yes. Okay, so repeat again, mirror there, straight line, yes. Mirror again, okay, we need to mirror again, yes. Mirror again this one, go there, yes. Mirror again the other one, mirror about some places in the center, yes, and then delete the source object. Mirror again that one about some point there, then yes. Okay, then mirror again, and then mirror from there, then yes. Okay, then I'm going to mirror this again. So this time I'm going to put a little bit, but it's okay. I think it will just arrange itself because the mirror is confusing. Yes, so yeah, like that. Mirror again, mirror about some midpoint there, yes. going to mirror this from about that point. Yes, delete the original point. Then I can move this because the two okay. Then I can mirror this. About is just enter. Yes. And I can mirror that. Put some point there. Yes. Then I can come here and then I'll just do it all of it together. Can mirror this about, and then yes, and then I can select all of them. I select this, select similar. Okay, delete all those. And then I can select this, select similar, then properties, then our rotation need to be 0 for all of them. Okay, then I need to delete this. Sorry for that. Then, sorry for that, I'm gonna need to delete those. So I think I've done my detailing, I'm finished. So that's how we go about it, guys. So I've finished detailing my beams. You can see if you print this, very okay. So thank you guys, please support my channel, please subscribe for my channel, and welcome again. Okay, that will really be appreciated. Thank you.